All right, please fill out notes as you watch this video. Multiplication properties of exponents. Lesson 8.3. Multiplying powers with the same base. A to the m multiplied by a to the n. Well, we see that both of those powers have a base of a. Both of the powers have a base of a. So the rule says that if the bases are the same, I can actually add the exponents. So when the bases are the same, I can add the exponents. So a to the power of m multiplied by a to the power of n equals a to the m plus n. All right, let's do a couple of real-life examples. Number 1, 9 squared multiplied by 9 cubed multiplied by 9 to the 5th. You'll see that those all have a base of 9. So using the rule, because the bases are the same, I can rewrite it as 9 squared plus 3 plus 5, or 9 to the power of 2 plus power of 3 plus the power of 5 equals 9 to the power of 10. Again, you're just adding the exponents. Let's try another example. 4 to the power of 5 multiplied by 4 to the power of negative 3. Again, the bases are the same, so I rewrite this as 4 to the power of 5 minus 3, which is the same thing as 4 squared. Again, when the bases are the same, you add the exponents. Let's try using rewriting these expressions using each base only once. I have 5 squared multiplied by 5 to the 7. Sorry, 5 cubed multiplied by 5 to the 7. Again, you'll see that because the bases are the same, I add the 3 and the 7, and I get 5 to the power of 10. In our second example, I have 2 to the negative 4th power multiplied by 2 to the 9th. Negative 4 plus 9 is 5, so I have 2 to the 5th power. In our third example, I'm combining my bases. I find the bases that are the same. I have a to the positive 4th power and a to the negative 4th power. I add those together. I also have b to the negative 3rd and b to the 6th, and then I have c to the 3rd. So I'm only combining the like terms, or the bases that are the same. A to the 4 minus 4 is a to the 0. And from yesterday's lesson, you remember a to the 0 is the same thing as 1. B to the negative 3 plus 6 is b cubed. And c cubed is just going to stay c cubed. So I have 1 times b cubed multiplied by c cubed, which is the same thing as b cubed multiplied by c cubed. All right, so in this example, you'll see that we have variables and coefficients. We are going to multiply the constants or the coefficients. So in our first example, I need to rewrite multiply coefficients. All right, so in our first example, I have 5x multiplied by 2y to the 4th multiplied by 3x to the 8th. I am first of all going to multiply the coefficients. So I'm going to multiply 5 times 2 times 3. And then I'm going to find the bases that are the same. I see that I have 2 x's. And I'm going to multiply x to the power of 1 plus 8. And then lastly, y to the 4th. So let's see, 5 times 2 is 10, multiplied by 3 is 30, x to the 1 plus 8 is x to the 9th, y to the 4th. Let's look at the second example. Again, I multiply the coefficients. 2 times 7 times 2. I also need to group together the exponents and bases that are the same. I have 2 y's and only 1 x. I'm going to try to preserve ABC order and put my x first. X squared multiplied by y to the 3 plus 4. When I simplify, 2 times 7 times 2 is 28. X squared y to the 7. In our last example, I have 4 multiplied by 3 multiplied by 4. That is going to equal 48. I have the x cubed all by itself. That is the only x base. And then the y's, I have y to the negative 2 plus y to the 5th, or y to the negative 2 plus 5 power. When I simplify, I have 48 x cubed y cubed. Our last two examples are with multiplying numbers in scientific notation. Remember, with scientific notation, we can only have one number to the left of the decimal. One number to the left of the decimal. Same as our previous examples, we are going to multiply the constants or the coefficients, and then we're going to use the rules for multiplying exponents. If the bases are the same, we are going to add the exponents. So if we look at example A, I have 4 times 10 squared multiplied by 4 times 10 to the 5th. So 4 times 4 is 16. And then I'm going to use the base rule for exponents. My bases are the same. So I'm going to rewrite that multiplied by 10 to the 2 plus 5. So I said earlier, 4 times 4 is 16, multiplied by 10 to the 7th. However, we're violating the rule for scientific notation, saying that we can only have one decimal place to the right. So I need to add a decimal place. So I need to rewrite 16 as 1.6. And when I make my number smaller, I've gone from 16 to 1.6, I need to add an exponent or add a power. So that will be multiplied by 10 to the 8th. Let's look at example B. Example B has 2 multiplied by 10 to the 6th power, and then that is multiplied by 10 to the negative 3 power. So again, the bases are the same, so I am going to add those exponents. And I end up with 2 times 10 to the power of 6 minus 3, or 2 times 10 to the 3rd. And that's it. Your homework is on page 407, 3 through 27, multiples of 3, 33 through 45, multiples of 3, 48, and 51. Good luck.